A young puma was born in the mountains of Patagonia in early spring. She had never seen prey. She had never been hungry in the way that forces a decision. Her mother brought food. The food appeared. That was the extent of her experience with survival. But every morning, without fail, she did something strange. She would find a rock, the same kind of rock, always elevated, always with a clear sightline in front of it. She would crouch behind it. She would wait completely still for several minutes. Then she would explode forward, covering exactly the distance a fleeing guanaco would cover before slowing, and at the end of that movement, she would twist her neck and bite down on empty air. Precisely where the spine meets the skull of an animal that wasn't there. Nobody taught her this. No older puma demonstrated the sequence. She had never watched a successful hunt. She arrived in the world and within weeks, began rehearsing the most important thing she would ever do. The first time she made a real kill, she did not hesitate. She did not fumble. The bite landed exactly where it needed to land. She had already done it 1,000 times. Most people, when they watch young animals play, see joy. They see chaos. Kittens tumbling over each other, puppies chasing nothing, bear cubs wrestling on a hillside. What they are actually watching is something far more precise than it looks. In 1998, ethologist Mark B. Koff published research that would quietly change how scientists understood animal play. He wasn't arguing that animals didn't experience joy, he believed they did. What he found was that play, in virtually every species studied, was not random. It followed patterns. It rehearsed specific sequences. It produced, with remarkable consistency, the exact behaviors the animal would need most in adulthood. Not similar behaviors, not related behaviors, the exact behaviors. The same movement sequences, the same timing, the same precision. Play wasn't the opposite of seriousness. It was seriousness in disguise. Here is what that means for the puma. The crouch behind the rock is not accidental. Pumas hunt from elevated positions with concealment. The elevated rock is the template her nervous system was born with. She didn't choose it. She was drawn to it the way water moves downhill, following a gradient she didn't design and couldn't explain. The distance she covers in her mock lunge is not random. It matches within close margins, the distance at which a guanaco transitions from walk to sprint. Too early and the prey gets a head start it can sustain. Too late and the angle of approach collapses. The puma's body knew the right moment before she had ever experienced a wrong. And the bite to the back of the neck, to the exact junction where the spinal cord is most accessible. That is not a behavior she assembled from experience. It is encoded. Present at birth, activated through practice, refined through repetition, until it is indistinguishable from mastery. What is happening in this animal is not learning in the way we usually mean the word. It is something closer to remembering. The body already knows. The practice is just the process of making conscious what was always already there. This is not unique to large predators. The pattern shows up across the animal kingdom in ways that are difficult to explain once you start looking for them. Young dolphins practice echolocation before they need to hunt. They emit clicks into empty water, map the returns, adjust the frequency. They are calibrating a system whose output they have never used for survival. They do it anyway, thousands of times before their first real hunt. Juvenile ravens, which will later become some of the most sophisticated problem solvers in the animal world, spend hours manipulating objects with no food reward, moving sticks, pulling strings, dismantling structures. No one watches, nothing is gained. They are practicing manipulation for its own sake, building a toolkit they won't need for months. Young chimpanzees in West Africa carry sticks in a way that closely resembles the way their mothers carry infants. Female juveniles do this significantly more than males. They have no infants. There is no instruction. But for hours each day, some of them tend to sticks with a care that researchers can only describe as maternal. They are rehearsing motherhood before they are old enough to become mothers. In each case, the animal is practicing something it has never done. In each case, the practice is precise. In each case, the adult version of the behavior, when it finally appears under real conditions, arrives not rough and uncertain but polished. As if it had been done 1,000 times before. Because it had. The scientific explanation for this is elegant and slightly unsettling. The nervous system doesn't wait for experience to begin building itself. It builds in advance, using a blueprint that evolution has been refining for millions of years. The puma's neural pathways for hunting, the specific sequences of crouch, wait, lunge, bite, are partially preformed at birth. They exist as potential, as tendency, as something waiting to be activated. Play activates them. Not randomly, but in the precise order the behavior will eventually need to occur. Each repetition strengthens the pathway slightly. Each practice session is, at the neurological level, nearly identical to a real hunt, except without the cost of failure. This is why young animals can perform adult behaviors so accurately on the first real attempt. They have been performing them all along. The nervous system cannot distinguish between the rehearsal and the reality. Every mock lunge the puma made in that field was, to her neurons, a hunt. The prey was imaginary, the learning was real. Researchers who study this process call it experience-expectant development. The nervous system expects certain inputs, certain patterns of movement, certain sensory feedback, and uses them to complete its own construction. Take away the play, and the adult behavior suffers. Give it back, and the animal arrives at adulthood with capacities that look, from the outside, like innate genius. They are not genius, they are preparation so thorough it becomes indistinguishable from talent. There is something in this that most humans recognize without quite being able to name. Think about the things you were good at before you had any right to be. The skills that arrived before the experience that should have produced them. The child who could draw before anyone taught them proportion. The teenager who understood music before they understood theory. The person who knew, somehow, how to hold a grieving friend, the very first time someone they loved needed that from them. We call these things gifts. We call them talent. We assume they came from somewhere outside the normal process of learning. But the animals suggest something different. They suggest that some of what we experience as natural ability is actually the surface of something much older, patterns laid down so deep in the structure of the nervous system that they predate individual experience entirely, not gifts from nowhere. Rehearsals from before. The puma did not invent her hunting sequence, she remembered it. She practiced it until the memory became fluent, and then, when the moment came, she used it. There is a harder question underneath all of this. If the puma's most important skill was already there at birth, waiting preformed, ready to be activated through practice, then what exactly was the practice for? The answer the research points toward is uncomfortable in the best possible way. The practice wasn't to create the skill was already there. The practice was to make the animal worthy of it, to build the muscle memory around the neural blueprint, to synchronize the body with the knowledge the body already carried. The puma spent weeks practicing a kill she already knew how to make. She did it in the dark, alone, biting empty air, with no audience and no reward. And when the guanaco finally appeared, real fast, alive, she was ready. Not because she had learned. Because she had already arrived.